Today we're talking about power. Okay? Who knows what power is? Does anybody know anything about power? No? Well, we hear that things are powerful all the time, don't we?
Right.
Okay, so we need to figure out what that means because I'm not really sure, right? Now, I'm kidding, I know. So if we're dealing with power and it's connected to work, power must have something to do with work. What do you think power has to do with work?
Maybe the increase of work.
Increased strength, okay? It has to do with time, okay? Now, if something has a lot of power, do you think that means that the work that's being done is being done fast or that it's being done slow? Fast, okay? So the faster we do work, the more power we have. So power is how fast we get work done, which means that our equation is that power is equal to work divided by time, which means P equals W over T. Okay? Now, does anybody have a guess at what the unit is for power? Haha, yeah. You caught it, okay? So, the unit for power is a watt. Okay? That's how we say joules per second, because wouldn't that be what it was if we didn't have an overall unit for it? Okay, so a watt is our unit that we are going to be using for power. Now, another unit that we sometimes use is called a horsepower, okay? And 1 horsepower is equivalent to 746 watts. Because you guys have heard people talk about the horsepowers on their car and things like that, right? Mm-hmm. Okay, so this is where it comes from. It is a real thing that has some validity to it, okay? Now, if something has more horsepower, that means it does work fast or slow?
Faster.
Does it faster? Okay, good. Now, let's think about all of this in forms of an example, okay? So we're going to say it takes an 80-kilogram person 22 seconds to go up a flight of stairs. And overall, during that flight of stairs, they're going to have gone a distance of 3.7 meters, okay? And we want to know first how much work they do and then how much power. So let's list out what our knowns are from this. Kilograms is mass, yeah. So what is our mass? 80 kilograms, perfect. What else were we given?
I think 2.2 something. I don't know what it was though.
Yeah, we were given a distance. What was our distance? Do you guys remember?
2.2.
3.7?
Okay.
3.7 meters. Okay, let's see if we were given anything else. The 22 was time. That's how many seconds it took us. So time equals 22 seconds, okay? Now for part A, we want to know how much work was done. And what are the units for work?
Watts.
Joules. And for part B, we're going to want to know how much power was done, which is in watts. So to start part A, what is our equation for work? It's what times what? F times what? D. Force times distance. Okay. We have distance. Do we have force? How are we going to find force? But we don't have work.
Is it mass times acceleration?
Yes, it is mass times acceleration, okay? Now, when we solve for the force of an object, we take its mass, so here it'll be 80 kilograms, and we multiply it by its acceleration. What's the acceleration we use? 9.8. Awesome. Okay, so when you think you have the force, just the force, let me know what the force is. What are the units? Newtons. Okay, so 784 newtons. We all agree with that? All right, awesome. now we can figure out the work, right?
Right.
We're going to want to take that 784 newtons, and what are we multiplying it by?
The distance.
Yes, the distance, which is the 3.7 meters. So when you think you have the work, you said 2,000 what?
928.
What would be the units on that?
Joules.
Joules. Does everybody agree with this number?
2,928.
2009. Oh, 0.28?
No,
0.8.
Oh, okay. So it's 9,000 what? 200?
Zeros. No,
there's
2,900.
Oh my gosh.
2,928. At this point, what's your number?
2,900.8.
What are the units?
I think it's because of my math.
No. The reason it's just like with so many people talking at once, I just can't hear. I've told you guys I have horrible hearing a million times. Okay, so that's the answer to part A, right?
Yes. Yes.
Okay, so part B. What is our equation for power?
W over T, or work over time.
Perfect. So do we have to rearrange anything?
No.
No, we're just going to take that work we found.
Mm-hmm.
And then what are we dividing it by?
Time,
Which is?
22 seconds.
22 seconds. All right, awesome. When you think you have the power, let me know.
131.885.
I agree with that.
131.85 watts. Do you guys all agree with that?
Yes.
I agree with that. And look at that. Just like that, you did your first example. How was it? Good. Am I clear to erase? Okay, I'll give it a second. I'll erase the knowns. How about that? Erase the knowns. Now, while I'm erasing, I've got a question for you guys. Show of hands. Who has been to the Empire State Building in New York City? Okay, so those of you who have been, it's a really short building, right?
Yeah. That's the most dumbest thing.
It was a joke, Dan.
The shortest building.
It is a tall building, right?
Right.
Okay, those of you who have been there, did you go to the top?
Yeah.
Did you take the elevator or the stairs? Yeah, I took the elevator too, right? Now, to the tippy top, where you get to stand up there and see. Okay. So, interesting thing. There was this crazy person on February 3rd of 2003 who was like, you know what I'm going to do? I'm going to create the record for the fastest someone has run up the stairs in the Empire State Building. Okay? So, to give you an idea, there are 86 flights of stairs in the Empire State Building, totaling 1,576 steps. Okay? Each step has an elevation of 0.2 meters, and the person completed this in 9 minutes and 33 seconds. Okay? So, let's list out what knowns we just mentioned, though, okay? We mentioned, you heard 1.2 meters? It was 0.2 meters.
Oh, okay.
So how many steps were there?
A number.
A number.
Something.
There were this many steps, right?
Right.
And each step, how many meters were each step?
0.2.
Okay, per step, right? Okay. And how long did it take him or her to complete this? 9 minutes and how many seconds? 33. I know, it's hard to remember when I'm just speaking it out loud, okay? And the other thing that we're going to have is the mass of this runner was 70 kilograms, okay? We want to figure out how much power did they put out as they were climbing the Empire State Building. We want it in watts, and we want it in horsepower. So, looking at this, what's the first thing we should probably do before we even start writing down equations?
Convert time.
Make your time to all.
Yeah, we need to convert time, and then what else do we need to do?
Convert steps.
Yeah, we need to figure out exactly how many meters we went so we can have a solid distance, okay? So, since you guys mentioned time first, we'll start out there.
573 seconds.
So, we've got 9 minutes. How do we convert that to seconds? so what is 9 times 60? A lot.
Oh, it's
540, and then you add your 33,
Yep, and then you're gonna add your 33 seconds. So overall, what's our time?
573.
573. Okay, so that's how many seconds it took. Then, how do we find out the distance we traveled if we went this many steps and each step is gonna take us that far?
Multiply that.
We're gonna do 1,576 times 0.20 meters. So what's that gonna give us?
315.2.
Okay, sorry, what is it?
315.
Okay, what do I need to go back to? I was told that I'm talking too fast. I'm sorry.
I was figuring out how to multiply that.
Okay, the reason we multiply them is because every step has an elevation of 0.2, and there's this many steps. So this is how we get a distance. We have to multiply them together to get a distance of how far did we go. So what I'm gonna do is I'm gonna replace these ones that we don't wanna use with these actual numbers to give us some space back over here, okay? So we're gonna have that we want a distance of 315.2 meters, and then it took us a time of 573 seconds, okay? And we were asked to find power. So how do we want to go about finding the power? Work first? Okay. So how are we going to find the work?
Force times distance.
Oh yeah, you guys are right to find the force. We are going to do mass times acceleration. Good job. So we'll take that 70 kilograms and we'll multiply it by what?
9.8. Yeah, you are.
Okay, so what is our force here? 686, is that just straight? What are the units? Okay, now what do we do to find the work?
Multiply by distance.
Yeah, we're gonna take that force we just found and we're gonna multiply it by our distance. Don't forget our distance we found is 315.2 meters. So, how much work did we do?
216,227.
Yeah.
216,227?
Mm-hmm.
227.2.
Yeah.
What are the units?
Joules.
That is a lot of work. Okay, now that we have the work, can we find the power?
Yeah.
Okay, so power is equal to what?
Work over time.
Okay, do we have to rearrange anything?
No, you just divide that by 573.
Correct. We're going to do the 216,227.2 joules divided by 573 seconds. And what does that give us as our power?
377.36.
377.36?
Mm-hmm.
What are the units?
Watts.
Watts. Okay, so how many horsepower is that?
You gotta divide that by 714.
So we're going to take 377.36 watts. And to get it into horsepower, we know that 1 horsepower has how many watts? Okay, that'll cancel out the watts and we'll be left with horsepower.
So 0.51.
Okay, is there any part of this I need to go back to? Yeah, just because to get to horsepower. So this is the regular power right here, the 377.36. But to get to horsepower, we would say that in 1 horsepower, there's 746 watts. We put that on the bottom so the watts cancel. So yeah, you end up dividing them to get 0.51 horsepower. All right, now something that a few more people might be able to relate to. Have you ever had to pass a slow truck?
Yes.
Okay, that's going to be what our next problem's about, okay? Passing a slow truck. I had to do that on my way to work this morning.
Or like when you're trying to pass a mailman or a garbage truck,
Oh gosh, that's the worst.
but then the other lane is the other direction, so you kind of can't really do that with your hands.
You just got to like cross your fingers and hope for the best. All right, so we got a slow moving moving truck that we want to pass, all right? So our car is going to have a mass. Make sure to make out your notes. The mass is 1.3 times 10 to the 3 kilograms, all right? And it says that we want to accelerate from 13.4 meters per second to 17.9 meters per second in 3 seconds and figure out what is the minimum power required to do this. So the time is 3 seconds. Good job. What do you think the 13.4 is? Yeah, do you guys all agree that it's V naught?
Yep.
So what is the 17.9 meters per second? Final velocity. What did I say it was? 17 point what? 9. Awesome. And what are we asked to find?
The medium?
The power, right?
Oh, I thought you said medium.
No. Well, I said the minimum power
Oh.
required. Yeah. So we're going to solve for power. Like, how much power does that take? Okay. So we don't have distance, do we?
No.
So that means we can't use that work is equal to force times distance. So what else do we know that work is equal to? What about energy?
The change of the kinetic plus potential equals.
It's the change in kinetic energy, you guys.
Oh.
Work is equal to the change in kinetic energy. So that means 1/2 mvf squared minus 1/2 mv naught squared. Okay, so do we have everything we need to solve for our work?
Yes.
Okay, so let's do that then. Do we have to rearrange anything?
No.
Perfect. So we're going to take 1/2 times that mass.
Oh, can you do that?
Times 17.9 meters per second. And remember, that's going to be squared, right? Minus 1/2, 1.3 times 10 to the 3 kilograms. I'm going to run out of space. Times 13.4 meters per second squared. Woo! Ran out of space there at the end. Okay. So let me know when you have the work done. When you know how much work we did. What'd you get? It's going to be a big number.
91,552.5.
What are the units? Does everybody agree with that?
Yes.
Yeah?
Yeah. Took a while, but yes.
Okay. So now that we have the work, can we get the power? Okay, because power is equal to?
Work over time.
So do we have to rearrange anything? No, so we're going to take that 91,552.5 joules. And what are we dividing it by? Yeah, our time of 3 seconds. So what is that going to give us as our power?
30,517.5.
30,017.5?
517.5.
Okay. 517. What are the units? Watt are the units.
Right. Yeah,
Yes.
power.
Woo, we made it. Okay, so this same problem, let's consider, okay, we sped up, right? In 3 seconds, we sped up to this. But the truck is being mean. And you know how a lot of times when you speed up and somebody knows you're trying to pass them, they speed up too?
Mm-hmm.
I hate it. Okay, so the truck is going to speed up too, okay? And what's going to happen is that now our initial velocity is going to be that 17.9 meters per second. And we're going to kick it up a notch to a final velocity of 22.4 meters per second. And while doing this, we're going to use up the exact same amount of power, okay? So we want to know how much time does it take us to do that? So I'll put the power down here so that we can erase this and think about it, okay? So this was our power. So while you're thinking right now, what do you think our first step might be?
On the work.
We got to find the work again. Okay, so you guys know how to find the work, right? So tell me when you think you have what the work is. I just want the work.
Is it negative?
Huh?
Is it negative?
Is it 11? Oh, wait.
I don't know. Tell me what you think it is.
117,877.5.
What would be the units?
Um,
Joules, right? Does anybody agree with that or disagree with that? We all agree?
Yeah, but it came out negative.
I got 6.5.
It shouldn't have came out negative because this number is smaller than this number. Okay, so now that we have that, and we know that power is equal to work divided by time, how do we get time alone? What can we do with the t? We can multiply it, right, to get it up on top now. And then what's the last thing we have to move? Yeah, we're going to want to divide by p. So if we take work divided by power, we should get how long it takes. So how about you guys let me know how long it takes?
Yeah, 3.86.
What are the units? Did everybody get that? We took the work that we just solved for, and we divided it by this power we had found previously. That's what we did to get this time. Does everybody agree with that time? Yeah, I still see some really confused faces out there. Is there something I need to re-explain? Yes. Go for it. Are we okay?
Yes.
Okay. Like I said, I just see some concerning eyes still, so sadly, I'm not a mind reader. Okay, so something else I want to show you guys is we know that power is equal to work divided by time, right? And we know that work is force times distance, right? So we can write that as force times d over t, correct? What is d over t? Distance divided by time, what is that? Distance is in meters, time is in seconds. Velocity. So power can equal work divided by time and force times velocity. I just derived it.
Wait, say what you just said again.
Huh?
Say what you just said again. About the
Okay. So we know that power is equal to work over time. We know that work is defined as force times distance, right? Which can be written as that force times distance over time. And we know from previous knowledge in this course that distance divided by time is velocity.
Right.
Which means we can write it as force times velocity.
power.
Yeah, so power, it can either be work over time or force times velocity. So I'm going to do an example with you guys where you see where this one would come in handy and make your life easier, okay? Okay?
Divided by time as well.
No, because the distance divided by time is velocity. Because you guys know, what are the units for velocity? Meters per second, which is distance over time. Can I erase it now? No. Okay. I'm gonna erase it.
Yes, it's the.
I don't know
that
why.
big one.
I like the ones here, clipboard.
Do you have it now?
But I plugged it in.
You have it now?
Yeah, I probably just plugged it in.
Okay, so let's do an example where we're going to want to use this, okay? So listen to the problem. It takes a force of 1,280 newtons to keep a 1,500 kilogram car moving with constant speed up a slope of 5 degrees. If the engine delivers 50 horsepower to the drive wheels, what is the maximum speed of the car? I get that that sounds like a lot. Your mind's about to be blown when you see how little we have to do to get to the answer, okay? It's honestly going to be the shortest problem we've done, actually. So the first thing we're told is that we have a force of 1,280 newtons, right? Okay. Then we are told that our car is 1,500 kilograms. That's its mass. Next, we get told that there is a slope of 5 degrees. And then we finally get told that it has a power of 50 horsepower. And we were asked to just find what is its velocity. Now, I have some really good news for you guys. This angle, we don't care about that angle at all. We really don't. Not one bit, okay? So that should be one sigh of relief. I know when we see angles, we get stressed. We don't need the angle, okay? So what should we do with this 50 horsepowers, though?
12/7/46.
We're going to say that we know that there are 746 watts in 1 horsepower, and that's going to give us our power in watts, so we can use it.
37,300.
37,300? Did everybody else get that?
Yeah.
What are the units? Watts, right? Okay. So now we have power, we have force, we just need velocity. And we just saw that power is equal to force times velocity. So what's the one thing we have to do? Yeah, just divide by force to get our velocity. So that means we'll take this 37,300 watts and divide it by our force of 1,280 newtons.
29.14.
What are the units?
Meters per second.
Meters per
I was
second.
like, I was struggling on.
You guys see how this connects to everything else we've been doing? Sure. It's working kinetic energy. Come on. All right. Yes, ma'am. Yes. Huh? Nope. You ended up not needing the mass either because you already had the force.
Right.
Okay. Any questions about this? No? Okay.